Have you ever thought of the entire universe as, well, one giant kitchen? Because in a way, it is. Everything you see, from the stars way out there to the phone in your hand, is made following a specific set of instructions, a kind of cosmic recipe book. And that book? It's chemistry. So in this explainer, we're going to learn how to read it.
Okay, so you know any good recipe needs exact amounts, right? You can't just wing it. But what happens when your ingredients are atoms? I mean, they're so small you can't see them, let alone count them one by one. How on earth do you get the measurements right? That's the first huge problem every chemist has to solve.
Well, to get around this, chemists came up with a pretty ingenious workaround. They figured if you can't count the ingredients one at a time, you just need a bigger measuring cup, a special counting unit. You could call it the chemist's dozen.
And that special unit is called the mole. Now, the name might sound a little weird, but don't let it throw you. A mole is just a word for a number, exactly like how dozen means 12. The big difference is that a mole stands for a number that is, well, it's just mind-bogglingly bigger than 12.
And we have this guy to thank for it, Avogadro, a 19th century scientist. He was one of the first people to really connect the dots between the volume of a gas and how many tiny particles were actually in it. His work basically paved the way for us to finally count the uncountable.
So, just how big is this chemist's dozen? It's that number. That's 602 sectillion. It's a number so huge, it's hard to even wrap your head around. To put it in perspective, if you had 1 mole of donuts, they would cover the entire surface of the Earth in a layer 5 miles deep. That's the insane scale we're talking about here.
All right, so now that we know how to count our ingredients, let's talk about the basic techniques. What can we actually do with all these atoms and molecules once we've measured them out? What are the fundamental rules of chemical cooking?
Well, it turns out that most of the millions of chemical reactions out there really just boil down to 3 simple moves you'd recognize from your own kitchen. You're either putting things together, taking them apart, or swapping one ingredient out for another. Let's take a quick look at each.
First up, we have combination. This is the simplest recipe of all. You take 2 or more basic ingredients and you just combine them into one new, more complex thing. Like you see here, a sulfur atom meets up with an oxygen molecule and boom, you get sulfur dioxide. Simple as that.
Now, what if we wanted to do the exact opposite? That's called decomposition. It's basically like unbaking a cake. You start with one complex thing and you break it back down into its simpler parts.
And here's a perfect real-world example. You take this reddish powder, mercury oxide, and you just heat it up. That heat gives it enough energy to literally snap the bonds holding it together, and it breaks apart, leaving you with shiny liquid mercury and releasing pure oxygen gas.
Okay, so we've got our ingredients counted out in moles, and we know our basic moves: combine, break apart, swap. Now it's time for maybe the most important part, reading the actual recipe card.
In chemistry, this recipe card has a pretty fancy name: stoichiometry. I know it's a big word, but the idea behind it is super simple. It's just the part of the recipe that tells you the exact proportions. Not just what to mix, but exactly how much of everything you need.
And the #1 rule of stoichiometry, the golden rule of all chemical cooking, is this: you can't create or destroy anything. The atoms you start with on the left, your ingredients, have to exactly equal the atoms you end up with on the right, your final dish. The scales always have to be balanced.
And this idea of a precise, perfectly balanced recipe, it's absolutely everything. Because when you get it right, you can create something life-saving. But if you get it even a little bit wrong, the results can be catastrophic.
See, the universe is just going to follow the recipe you give it, no questions asked. So, what happens when we accidentally give it a bad one?
Let's take something simple, like the flame on your gas stove. When you have plenty of oxygen, you get a good recipe. The methane burns completely and creates harmless carbon dioxide. But if you starve that flame of oxygen, the recipe changes. The combustion is incomplete, and instead it starts producing carbon monoxide, a deadly poison.
And what makes carbon monoxide so dangerous is that you can't see it or smell it. It's a true silent killer. When you breathe it in, it latches onto the hemoglobin in your red blood cells way more tightly than oxygen can. It basically hijacks your own body's delivery system and starves your cells of the oxygen they need to survive.
And you can see how quickly this gets serious. When just 10% of your hemoglobin is carrying carbon monoxide, you might just feel short of breath. But at 30%, you're talking dizziness and confusion. And if it hits 50%, it can be fatal. It's a pretty intense reminder that in chemistry, the recipe isn't just a suggestion, it's everything.
But enough about bad recipes. Because when chemists get the recipe perfectly right, well, that's when the magic happens. It's the foundation of pretty much our entire modern world.
And these perfect recipes are all around us. For example, a 35% concentration of alcohol in water is what lets us make the vanilla extract we use for baking. But on the other hand, a super precise 0.9% concentration of salt in water creates the medical saline solution that's safe to put directly into your bloodstream. Any more or any less could cause serious problems. Precision is the name of the game.
And really, that's what it all boils down to. Chemistry isn't just some abstract subject you learn in school. It is literally the instruction manual for reality. Every single thing, from the medicine that heals us to the food that nourishes us, is the product of a very, very precise chemical recipe.
So, the next time you cook a meal or take some medicine, or even just take a breath, take a second to think about the incredible chemistry making it all possible. And ask yourself, what other cosmic recipes are shaping the world all around you, right at this very moment?